Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Arafika Zaraputri from class 11 Science 1. In this occasion, me and my friends will do a physics experiment, namely resonance and simple sounds on a bottle syrup, guided by Miss Fitri Wulandari, Bachelor of Education. The purpose of this experiment is to determine the effect of space length with the frequency of sound scales and to explain why the sound changes as we add the water.
Hi, my name is Ayu Devina Minudin.
Hello everyone, my name is Fatia Rosalia Tarifah. Me and Devina will perform Ibu Kita Kartini after this. Enjoy!
Ibu kita Kartini, putri sejati, putri Indonesia, harum namanya. Ibu kita Kartini, pendekar bangsa, pendekar kaumnya untuk merdeka. Wahai ibu kita Kartini, putri yang mulia, sungguh besar cita-citanya bagi Indonesia.
I'm Fayaza Tunisa. You have seen the performance before, right? Is it really cool, guys? Of course yes, right? But if you think about it, how come just with the bottle and the water can produce the tones, even the different tones? So I will explain it special for you guys. Each bottle of a syrup has a different volume of the water, so that it has a different length of the empty space in the bottle. With this different length of the empty spaces, the syrup bottles can produce the different tones. A syrup bottle with the more empty space will produce a lot of sound when we hit it than a syrup bottle with a less empty space. Why it can be happen? This can be happen because the frequency that produced in a syrup bottle with a little volume has a more empty space, so that is large enough to produce the louder sound. Likewise, a syrup bottle with a more volume has a less empty space and produce less frequency also. It can produce a sound as louder as the before. We can find the value of the frequency by dividing the speed of sound propagation in the air and by 4 times of the length of the empty space in the bottle as a basic terms. Like that, when she hit the syrup bottle, there is one thing that happened. It is a sound resonance. When the syrup bottle is hit, it will produce a resonant event because the vibration from the sound source caused the vibration of the air molecule in the empty space of the syrup bottle with the same frequency. This is still related as I said earlier. The more empty space in the bottle, the louder the sound is produced, the sound resonance will be stronger too. So, the length of the empty space is directly proportional to the loudness of the sound and directly proportional to the amount of sound resonance.
I'm Nadia, and I'm going to explain further regarding the science behind the bottle performance. So Farata has explained how the height of water, hence the length of air inside the bottle, affects the frequency of the sound produced, consequently the notes produced. And now I'm going to put the performance into calculations and proving the theory that Farata has explained before. So this is the bottle. The length of bottle that we use is 0.27 meters. And as you can see, from the top till the boundary between the air and the water, it is the length of air. And from that boundary to the bottom of the bottle is the length of water. And we have filled each bottle with different amount of water, resulting into different length of water and different length of air. This is the numbers as we have noted. As you can see, the water decrease for every notes going up, and the length of air increase for every notes going up. Now, this is the formula that we're going to use to calculate those sounds produced by those bottles before, and this is the formula for closed-ended pipes. As for the velocity of sound in the air, I'm going to use the average number, that is 343 MPS, and for length, we're going to take the numbers that I have shown before. And now, as you might have get the hang of it, for every notes like do, re, mi, fa, sol, la, si, every note are going to have different formulas, more exactly different constantas for the V. This is the first harmonic, or also the fundamental frequency, with the frequency of do equals to V over 4L. And it's going to increase. As for re, we have 3V over 4L. This is the second harmonic. And so on. From mi, fa, sol, it is the third and fourth and fifth and sixth until we reach do again. It's going to be different for every notes. Therefore, we're going to multiply the velocity of sound in the ear. Next, let's put the numbers provided before from V to L of all these notes into the formula. For this video, I have already calculated the frequency for you guys, and we're just gonna get through it. So as for do, the frequency is 775.5, and for re is 2143.7, and for mi, for fa, sol, la, si, do, you can see that the numbers keep increasing. Thus, this proves further the theory that Fayeza has explained about how the length of air inside the bottles affects the frequency. With the longer the length of the air, the higher the frequency because of the resonance of the water. As you can see, this proves the theory that Fayeza has explained regarding the length of the air and the resonance and so on about the frequency, about how the length of air is going to increase just as the frequency increase. Different frequency, just as it has different amount of water inside the bottle. Thank you.
Hi, I'm Adil Tarensyadiza, and here one step closer to close this presentation. Well guys, you know what if we look for the frequency value with the application and the frequency value manually by count on it with the accessed formula will be different. Well, it cannot be like that because first, there are many sounds that are detected, not just the sound of a bottle club. Second, the shape of the glass isn't straight, there are still curves. Third, the application detector isn't very valid because there is a possibility to get a bug, isn't? And yes, as the conclusion of the experiment we did, here we know that each bottle of syrup has a different volume of water, so it has a different length of space in a bottle. This different empty space, this syrup bottle can produce different tones. A syrup bottle with more empty space will produce a louder sound when you heat it than a syrup bottle with less empty space. This can happen because the frequency produced in the syrup bottle with a little volume of water has more empty space that is large enough to produce a louder sound. Likewise, the syrup bottle with more volume has less empty space and produces less frequency. We can find the value of the frequency by dividing the speed of sound propagation in air and 2 times the length of the empty space as the basic tone. When the syrup bottle is heated, it will produce a resonance even due to the vibration from the sound source, resulting in the vibration of air molecules in the empty space of the syrup bottle with the same frequency. The more empty space in bottle, the louder the sound, the stronger the resonance of the sound. Thank you so much. Catch you later.